This is a review of the Chapter 6 material, which is Systems of Equations and Inequalities. Number 1 asks us to solve the system of equations by substitution. Substitution works best when you have either an x or y that's already by itself on one side of your equation, or if that's not the case, if any of your x's or y's have coefficients of 1 or -1, because then you can quickly get it by itself. In the first equation, we see that the y has a coefficient of 1. So that's the equation we're going to start with. In order to get that y by itself, we would subtract 8x from both sides. So our new equation would look like y equals -8x minus 11. Now that y is by itself, we can take everything that y equals and plug it in for the y in the other equation. So we're going to rewrite everything, except instead of writing y, we're going to write -8x minus 11. So we have -5x plus 3. I'm going to put this in parentheses to remind us that we need to distribute. So instead of saying y, once again, we're saying -8x minus 11 equals 25. And if you substitute correctly, you should only be left with one of your variables. So here, my new equation only has x's, which means I can now solve for x. So I'm going to distribute my 3. I end up with -24x and -33. I can combine my like terms. So my x's give me -29x minus 33 equals 25. Add 33 to both sides means -29x equals 58. And divide both sides by -29, we get x equals -2. And now we can take that and plug it back into one of our equations to figure out the y. And really any of them work, but I'm looking at this and saying if I take this -2 and plug it in to that new equation I created, I'll get my answer very quickly. So I have y equals -8 times -2 minus 11, which is 16 minus 11, which is 5. So my final answer, we need to take our x and y and create an ordered pair, would be -2, 5. Remember, if you get nice integer numbers in your answer, always plug them back into the original equations and check to make sure it works. Number 2, we're solving this system of equations by elimination, which means we need to get our x's to have the same coefficient or our y's to get the same coefficient, and then we can either add or subtract our equations together. And there's a couple options here. Okay, I can take my first equation and multiply it by 2. Okay, and then I'll have 4x, and then I can subtract everything, and my x's will be eliminated. But I'm looking at this, and I like the fact that my y's have signs that are opposites. So I'm going to multiply my first equation by 2 and my second equation by 5. That gives me 4x plus 10y equals -2, and 20x minus 10y equals 10. And the reason I chose to deal with my y's is because now I have a 10y and a -10y. If I add my two equations together, my y's are eliminated. 4x plus 20x is 24x. -2 plus 10 is 8. If I divide both sides by 24, I just simplify that, and x is 1/3. And now I have to plug that in to find my y. Once again, does not matter which one. I'm just going to plug it in to my second one right here. So 4 times 1/3 minus 2y equals 2. Right, that's 4/3. If I subtract 4/3 from both sides, I need a common denominator here, so 2 can be rewritten as 6/3. So I end up with -2y equals 6/3 minus 4/3, which is 2/3. Okay, I would divide both sides by -2, which is really the same thing as multiplying by -1/2. My 2's reduce, and I get y equals -1/3. So my final answer is 1/3, negative 1/3. Next questions. Tell us to solve if possible. Okay. Looking at number 3, my y is already by itself, so I'm going to use the substitution method and take this stuff here and plug it in for my y. But you could have moved your x's over to the other side and used the elimination method if you chose. That's perfectly fine also. So if I substitute this stuff in for my y, I end up with 15x minus 3 times 5x minus 4 equals 12. Distribute gives me 15x minus 15x plus 12. If I combine my like terms, that goes away because that's 0. And I end up with 12 equals 12. And when you're doing systems of equations and both of your variables disappear, if you are left with a true statement, that means that anything will work. So one way you can say that is infinite solutions. I would totally accept that answer. If you want to be as specific as possible, okay, you can say all points on the line y equals 5x minus 4. Okay, so that really means that these are both the same equation. So any point on that line will work. And number 4, they're both in standard form, so I'm going to choose to eliminate. And I'm going to multiply my first equation by 2 because then I can eliminate my y's if I'm looking at it right there. So I'm going to have 8x minus 2y equals negative 8. And then my other equation would still be negative 8x plus 2y equals 2. And now when I go to add my two equations together on this one, 8x and negative 8x is 0. And negative 2y plus 2y is 0. So both of my variables disappeared, which means I have a 0 on the left side. And negative 8 plus 2 is negative 6. So when I went to eliminate my variable, both of them actually disappeared. I ended up with an untrue statement. 0 does not equal negative 6, which means that this system of equations has no solution. Or you can use the little symbol to say the same thing. Okay. Number 5 asks us to solve it graphically and algebraically. Okay, so I'm going to graph them first, and then I'm going to do it algebraically because in the end, when I do the algebra, it should work out to be the same spot where they intersect on my graph. In order to graph them, though, they do have to be in slope-intercept form. So I'm going to rewrite my two equations down here. Okay, I'd subtract 3x on my first one, so 2y equals negative 3x plus 8. Divide everything by 2. End up with negative 3 halves x plus 4. My other one I'd subtract 32, so 4y equals 2x minus 32. Divide by 4y equals 2 over 4 would be 1/2 x. Negative 32 divided by 4 would be negative 8. Okay, so graphing my first one has an intercept of 4 and a slope of negative 3 halves, so going to go down 3 and 2 right, down 3 and 2 right, down 3. I try to put as many points as possible on here, especially because when I go to connect my lines now, I can't use a ruler on my computer screen, so it's not going to look the best. But the more points I graph, okay, hopefully I will still see where they intersect. My other one has an intercept at negative 8 with a slope of 1/2. So going up 1 over 2. And, ooh, I do see they intersect. Going to connect my lines. Okay. And so according to my graph, they intersect at 6, negative 5. Okay, so now let's do this algebraically and make sure that that is indeed the case. Okay, so I'm looking at my equations, and One of them is not in standard form, so I'm going to, actually they're both not in standard form, so I'm going to just rearrange my first one to be 3x plus 2y equals 8. My other one, I'd have to subtract my 2x this side, and I would then have to subtract my 32 to get it to the other side. So now both of my equations are in standard form. Okay, I'm going to choose to, let's see, I'm going to get rid of my y's. Okay, so I'm going to multiply my first equation by -2. You could have totally done +2, but then you'd have to subtract. Okay, it's up to you. So I have -6x minus 4y equals -16. And then -2x plus 4y equals -32. I'm adding them together. I end up with -8x equal to a -48, which means that x equals 6. And I'm going to plug it back into one of my original equations. I'll do 2y plus 3x equals 8. So 2y plus 3 times 6. It's 2y plus 18. Subtract 18 from both sides, we get 2y equals -10. And divide both sides by 2, y equals -5. So that means 6, -5 is definitely our answer. If you do this question and what you get algebraically does not match your graph, something went wrong somewhere, so go back and try and find your mistake. Okay, next page, we have a word problem. Okay, so we have 45 coins, nickels and dimes. The total value of the coins is $3.60, and how many of each type does she have? So we need to set up our two equations. The first one's going to involve the number of coins we have. Okay, we have nickels and dimes, so I'm going to say n plus d altogether equals 45. The other one we're going to write is going to involve the value of those coins. So a nickel is 5 cents, so if we say 0.05n, that's going to be the value of all of my nickels. Dimes are 10 cents, so I'm going to say 0.1d, and then altogether that equals $3.60. Okay, and once again you have options. Okay, I'm going to choose to multiply my first equation by 0.1, but you could have gotten one of these by itself and substituted in. You could have done times 0.05. Once again, with these, lots of options. We have 0.1n plus 0.1d equals 45 times 0.1 would be 4.5. Just going to recopy my other equation right below it. I'm going to choose to subtract my two equations, and I'm going to show that big subtraction sign to show I'm subtracting every single part. So my d's are eliminated. 0.1n minus 0.05n is 0.05n. 4.5 minus 360 is 0.90. And then when you divide both sides by 0.05, you end up with n equals 18. And if we know that n plus d equals 45, and we have 18 nickels, okay, we could subtract and we find that d equals 27. Okay, so our final answer, remember word problems, we need to write this out and tell what this means. So our final answer is 18 nickels and 27 dimes. Okay, number 7 combines what you know about equations in standard form and graphing them, okay, aka finding some intercepts, and what you need to do when it comes to systems of linear equations. So we have a movie theater charging $5 for an adult and $2 for a child's ticket. For one show, they sold 45 tickets for $165. So our two equations that we can set up, okay, I'm going to say Normally I would say A and C, but because we're dealing with our coordinate plane here, I'm going to say adult is X and child is Y. Okay, so if they're $5 for an adult ticket, that would be 5X. It's $2 for a child ticket, that would be 2Y. Altogether, they sold $165. Okay, I'm actually going to change that on you. Okay, I think I changed it on my answer or the sheet that you're working on. So we're going to say 30 tickets for $90, and that's going to make our lives a little bit easier when we do this. So let me change that here. Okay, so it's going to be 5x plus 2y equals not 165, it's going to equal 90, and that looks better. Okay. And then our other equation, if they sold 30 tickets altogether, we can say x plus y equals 30. Okay. And if I'm graphing this on my coordinate plane, I can find some intercepts. So for my first one, my x-intercept, if I said the y is 0, 5x equals 90, means that my x-intercept is 18. And my y-intercept, if the x's were 0, would be 45. And this one here, it's nice. They would just both be 30. Okay, so I need my intercepts to go up to 45, so I'm going to say, let's go by 5s. Okay, on both axes. We do want to make sure we label, so I said my X was number of adult tickets. My Y is number of child tickets. Okay, so my first one, I have an x-intercept of 18, so that'd be about there. Try to get as good as we can. And our y-intercept is 45. Okay, you would use a ruler. I can't. Connect like that. Okay. For my other equation, both of the intercepts are 30. So I would use my ruler and connect those. And it appears that they intersect right there. Okay, which would be 10, 20. But once again, this is a word problem, so we're going to say that that means 10 adult tickets and 20 child tickets. We should probably plug those back in to make sure it does work. If we had 10 adult tickets, that'd be $50. Okay, child tickets are $2, so that'd be $40 if there's 20 of them, and that would mean that they sold $90 worth of tickets. Okay, and 10 and 20 together is 30, which were the 30 tickets sold. For these, we're going to graph each system of inequalities. Okay, so we're going to graph each linear inequality, and then we're going to find that one spot on the graph that would be shaded for both of our inequalities. These are both already in slope-intercept form, so that's nice. So I'm having an intercept at 2 and a slope of 2 over 1. Keep going. It's a less than, so that means it's going to be an not open circle. If it was just a regular, it would be open. Okay, it's a less than, so it's going to be a dashed line. So I'm going to do my best to make a dashed line through my points with some arrows at the end. Okay. And then the other one would be an intercept at -1. And then a slope of -1 as well. And that's going to look like that. Okay, but since it's greater than or equal to, that's going to be a solid line. Like that. And now we need to figure out where to shade. So if I look at my first inequality we had, it was less than 2x plus 2, and that's my red line. So I would want things that are below that red line. So I know that it's not going to be those two sections, so if I want I can put a little X through those because those are not good. It's going to be one of these here, this one or this one here. Okay, so I'll just shade real quick and we're going to erase, so it's either this one or this one. But we're not sure. Okay, so let's find out. For our other inequality, the blue one, we wanted greater than it. So in terms of our blue line, we want things above it. Okay, so if we have a choice of above or below, we're going to choose the one that's above it. So that's the part we would shade. For number 9, none of these are in slope-intercept form, so we need to fix that. For this one here, we would subtract 7 from both sides, get 3x is less than 24, which would be x is less than 8. For the next one, we'd subtract 6 from both sides, which means negative 2y is less than 14. Divide both sides by negative 2, have to flip that sign. Y is greater than negative 7. This one here, we would subtract 2x from both sides, divide by 3, and now we can graph. So our first one is x is less than 8. We should be thinking vux, so it's a vertical line at 8, which will be over here. It is a less than, so it's going to be a dashed line. Okay. And if we want things less than it, we want the things that are on the left-hand side of that line. So I know I'm not shading anything to the right. My second inequality is y is greater than negative 7. We should be thinking hoi. So it's going to be a horizontal line through negative 7. Once again, open, or dashed, I mean. So we're going to have a dashed line at negative 7 with some arrows. And we want things above that, because we want things greater than, so we're not shading down there. Okay, so this big section that's to the left of our first line and above our second line is kind of what we're going for right now. Let's look at our third and final line. We have an intercept of 2, a slope of negative 2/3, so down 2 over 3. It's a greater than, so it's going to be, once again, a dashed line. And we want things above it, so in terms of this final line now, we are going to shade things that are above it. Can't go past that vertical line, and we are good. Number 10, we need to write a system of equalities that represents our graph. Okay, let's start with our vertical one. Our vertical one, we should be thinking vux, so we know x is going to be by itself. Okay, it is a solid line, which means we know it's going to have the equal to there. Oops, it disappeared. Okay. Our number part would be negative 7. So now we need to decide, is it less than or equal to negative 7 or greater than or equal to negative 7? And if everything is to the right, those are all x's that are bigger than it. So it would be greater than or equal to negative 7. This bottom line looks like it would be the next easiest to do. Okay, I have a y-intercept of negative 5. I can see that my slope would be going up 3 and over 4 to the right, so it would be a positive 3/4 x. Okay, it's above the line, so we know it's greater than. And because it's solid, it's greater than or equal to. And the hardest one is that one up top, because I can't quite tell what that y-intercept is. I can approximate it, but because I don't have a point right on that y-intercept, that y-axis, okay, my slope does not work out that I would land on that y-axis if I used it. Okay, I can't figure it out just by looking at it. So we're going to need to plug things in. I'm going to call this dashed line. We need to plug things into y equals mx plus b. Okay, or you can do point slope form. Either one is fine. So y, okay, let's see, our slope would be down 2 and over 1, 2, 3, 4, 5, 6, 7. So our slope is negative 2/7. I'm going to choose another point. That would be 1, 2, 3, 4. It's a little hard to see with all this shading going on. But that ordered pair looks like it's going to be 4, 6. So I'm going to plug in the 6 as my y, the 4 as my x, and solve for my missing b. So I get negative 8/7. I would add 8/7 to both sides. But 6 would really be 42/7. So I figured out that my b is 50/7. So my equation would be y equals, I said negative 2/7x plus 50/7. So that would be the equation. But now let's see what inequality symbol I need. It's things that are less than it, it's below it, so it's going to be a less than. And since it's a dashed line, it's no equal to, so that is our final answer. The next ones deal with piecewise functions. Number 11 gives us a piecewise function and just asks us to evaluate some numbers. Remember, when a number's on the inside, this is our x value. So we need to determine which of the three cases each of these x's belongs to. If my x is 10, okay, that would mean that I'm looking at that last case, because this happens when x is greater than or equal to greater than or equal to 3. So I plug in 6 minus 2 times the 10. That'd be 6 minus 20, which would be negative 14. The next one is saying x is 2, and that's our middle case because 2 is in between 1 and 3. Okay, and that means that the value is just 3. Nothing to plug in there, we just had to figure out that that's what the case was. And the last one is f of 0, so when we plug in 0, that means it's this one up top when x is less than or equal to 1. So that's negative 2 times the absolute value of 0 plus 1. That would be the absolute value, negative 2 times the absolute value of 1, which means our answer is just negative 2. Number 12, we are actually graphing a piecewise function. So we're going to pretend this is y equals negative 2x plus 1, y equals 5x minus 4, but we're going to kind of cut off parts of our graph. So this one here would have an intercept at 1, and then going down 2 over 1. Okay. And I'm going to stop it there because that's only when x is less than or equal to 2. So here would be our x values. Okay, here's x of 2. Everything to the left of that is happening, so I'm going to go that way. Because that 2 is included in this graph, we have that closed circle there. So we have graphed the first part. The second part has an intercept at negative 4. Okay, so I'm going to put it there, but I'm going to kind of end up erasing some stuff. So it has an intercept at negative 4, and then it's going up 5 over 1. So 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. And I'm going to start, I'm going to put an open circle there because I know it's only when x is greater than 2. So that's kind of going to be my starting point. And then 1, 2, 3, 4. Oop, I ran a room. I'll just make one. Okay, so this part of the graph is going to be going off that way. And I'm just going to erase that y-intercept I graphed before because technically I don't need that there. Okay, so the left part of the graph is when x is less than or equal to 2. Since it was less than or equal to, we have that closed-in circle, and that is the line, negative 2x plus 1, but we just had to chop it off there, okay, because it's not for when x is greater than 2, it stops. Our second part of the line, when x is greater than 2, so open circle there, that was 5x minus 4, so that would be that line, but only for things that are bigger than 2. 13, write a piecewise function for the graph. Okay, it's going to start with y equals, or really you could technically do f of x equals, I guess, if you really want to. It does not matter. And we have two pieces of our graph. So I'm going to draw the braces. So first we need to identify what the line is and then what the condition is. This here is a horizontal line. Okay, so we should be thinking hoi, and so it's going to be y equals just a number, and that number would be -5. So y equals -5, but only when our x is, here's the restriction now, here's -1, and we want only the x's that are less than -1. So I'm going to say y is -5, comma, when x is less than -1. Our other one, let's see, I have that there. I'd say that's a good point to use. Okay, so that means if I want to find my slope and my intercept, y would equal 1, 2, 3 over 1. Y would equal 3x minus 1. And our condition, our restriction on this one, x would be greater than or equal to -1 as they go to the right. Okay. Last couple questions is a review of how to graph absolute value functions, because you might need to graph one of these when graphing a system of equations. In the first one, number 14, that +3 on the inside tells us to go left 3, and that +4 at the end tells us to go up 4. So our vertex is -3, +4. And then there is a slope of -2/5, so we're going to go down 2 and 5 to the right. And then down 2 and 5 to the right. And I can do the same thing on the other side. And that is what it's, oops, that was really bad. Okay, do that, okay. Vertex, like we said, was -3, 4. Domain, our x's go on and on forever. That's all real numbers. And the range, 4 is the biggest it can be, and can be anything less than it, so y is less than or equal to 4. In number 15, that -2 on the inside tells us to go right 2, and there's nothing at the end, so our vertex is 2, 0. Our slope is 5, so we go up 5 and 1 over. It's going to be a very skinny graph. Put our arrows on. Our domain, once again, is all real numbers. And our range here, our y's, have to be greater than or equal to 0.